Assalamualaikum and good day everyone. Today we will be presenting our project titled Using AI to Calculate Speed Based on Time and Distance Travel. This project was developed by a group of 4 members. I am Batrisha Gistina. My group members are Farisha, Nora and Mastura. Each of us contributed to different parts of the system design and analysis. In this presentation, we will explain how our system uses basic AI logic, looping and decision-making structures to calculate a vehicle's average speed and determine whether it stays within the legal speed limit based on the type of travel, either city or highway. In real-world situations, monitoring vehicle speed is very important to ensure road safety and compliance with traffic regulations. However, a journey does not always involve only one straight trip. It may consist of several travel segments, each with different distances and time taken. In addition, speed limits also vary depending on the place of travel, such as city roads or highways. Because of this, manually calculating the average speed for such journeys can be inefficient, especially when multiple segments are involved. Therefore, our group identified the need for a computer-based system that can automatically calculate average speed, handle multiple travel segments, and determine whether the speed limit is within the allowed limit or over the limit.
The main objective of our system is to allow users to input complete trip details such as trip name, place of travel, preferred speed unit, and number of travel segments. The system is designed to calculate the total distance and total time accurately by using a looping structure. Based on these accumulated values, the system calculates the average speed for the overall journey. Finally, the system evaluates the calculate speed using decision-making and nested decision structures to determine whether the speed is within limit or over limit based on the selected place of travel. To design the system clearly, we use several problem-solving tools such as the Problem Analysis Chart (PAC), Interactivity Chart (IC), and Input Processing Output (IPO). From the PAC, the given data includes the trip name, place of travel, number of segments, distance, and time for each segment. The required results are the total distance travelled, total time taken, average speed, and the speed status message. The processing involves summing all distance value and time values, calculating the average speed using the formula total distance divided by total time, and comparing the result with the speed limit. The IC shows how users interact with the system from the beginning until the final output, while the IPO clearly connect the input data, processing step, and output results. Next, I will pass to my groupmate, Shamimi.
Next, I will briefly explain how the algorithm works. The system starts by welcoming the user and asking for the trip name and number of segment. If the number of segment entered is more than 0, the system continues by asking the user to select the place of travel, either city or highway, followed by the preferred speed unit, which can be kilometer per hour or minute per second. These inputs are validated before proceeding further. A while loop is then used to repeatedly ask the user to enter the distance and time for each segment. During each iteration, the system accumulates the total distance and total time. After all segments have been processed, the system calculates the average speed. Using nested if-else statement, the system compares the calculated speed with the speed limit, which is 90 km per hour for city travel and 110 km per hour for highway travel, and then display the appropriate status. The flowchart visually represents this logic starting from user input, followed by validation, looping, calculation, and decision-making process. To ensure that the system logic is correct, we perform test checking using two examples, one for a highway trip and one for a city trip. The result from test checking match the expected output, which confirm that the algorithm and flowchart function correctly. Now I will pass to Nora Kalmila.
The system was implemented using the C programming language. The program includes user input handling, looping for multiple travel segments, speed unit conversion, and speed limit evaluation. Based on the output examples, the highway case result is an over limit status, while the city example result is at within limit status. This shows that the system performs accurate calculations and decision making based on user input. In conclusion, this mini project demonstrates how real-world speed calculation problem can be solved using basic AI logic, looping structures, and decision-making techniques. The system improves accuracy, reduces manual calculation errors, and help users quickly determine whether a journey complies with speed regulations. Through this project, we were able to strengthen our understanding of problem analysis, algorithm design, flow charting, and programming implementation. Thank you for listening, and that's all from us.